This video will train a text classifier using naive Bayes. And the goal is that we can input a sentence and the classifier will predict whether that is spam or ham. A ham meaning it's a desirable normal message, and spam meaning it's an undesirable message. So far we've only trained classifiers that would try to find the best fitting line to separate classes. The naive Bayes works a little differently, and that's by learning the distribution of the data per class. This is a picture of blog.dailydoseofds.com. So generative versus discriminative models. Take this image with a grain of salt because, can generate new data. We're likely not going to use naive Bayes to do that. What they mean is because they're learning the distribution of each class, it would be possible to generate a similar data point. Typically not used for classification tasks. Well, if you search the internet for naive Bayes, you will most likely find most of the examples will be classification tasks. But some of these listed below, like LDA, is more used for dimensionality reduction. Hidden Markov models has specific use cases in speech recognition, speech tagging, and tasks like that. Well, these on the other side are mostly for classification or forecasting. Naive Bayes. So why is it used? It's simple, relatively simple and fast on small data sets. The disadvantage is it assumes that every feature is independent rather than correlated. So let's, in our example for text classification, let's say we have a sentence with all kinds of words. It will see each word as an independent feature, I would say. Well, that's not always the case. So I linked some interesting resources below to help you understand in more detail how it works. So naive Bayes is a probabilistic model. So it's going to give the probability that it is class A or B or whatever classes you have, 1 or 0, by multiplying the likelihoods of the features for each class. So for class 1 and class 0, so yes and no. And then it's going to, the highest outcome is going to be the prediction. So in this case, with these input variables, it's going to predict that it's not a good time to play golf with these weather conditions. Video linked below who's going to explain it in better detail. So here you see in the video the probability that we can play the game and the probability that we cannot play the game. So the multiplication for yes and for no, highest outcome is going to be the class prediction. A video more specific to the exercise will be doing the spam ham classification. I should learn that a lot of bad words specific spammy words make the sentence a spam message. Do check out these links to gain a more in-depth understanding. I will continue with the exercise and I will post this notebook on both my Patreon and my own members only section, which you can unlock. Do also check out my products or go to my Patreon and get the notebooks there. Okay, so we begin by just installing our packages, Microsoft ML.NET and data analysis to inspect our data frames. I go over that more slowly in my previous videos. In the playlist ML Basics. Let's not forget our using statements. This time as input we only have the message in which every word will be featurized or become a feature. And the output is the label, so whether spam or ham. This prediction class is when we want to use our consumer model and have try to predict whether it's spam or not based on a message that we put into the model. Datapad, I use a SMS spam collection.tsv. This should be included in the zip file that I will post on Patreon and my own website. But if not, you can get the dataset here. I did have to turn it into TSV, but that's quite easy to do. Continue creating our ML context, loading our data, which contains the label and message, separated TSV, no header, yeah, that's good. The row count, just checking whether we're loading all of the data, which if we take a look. Oops, the last should be similar. 5574, yes. Then we turn this into a data frame for better inspection. Check the last records. So you see label ham and label spam, and then the message. This is like an SMS text. Normal texts, conversational text. Then the spam would be reminder to get 2.5 pounds, free call credit, blah, 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 blah. You have won a prize, call this, or whatever. Likely spam. Then I continue installing Scotplot to visualize the distribution between the classes, so the amount of samples we have per class for spam and for ham, which this code will show me. Some filters, so to get all the records that are spam and all the records that are ham. Quickly visualizing the spam ones to get an idea what is spam, better ID. And we'll see similar price and call me and cost stuff. Is ham seems to be more normal conversation. Visualizing it is spam is ham, just a row count for each class. And then we see we've got way more ham then we've got spam. This could bias our model towards predicting is ham for new data. Now, to featurize this text, we can't just work with the complete sentences, nor can we work with the words. We'll have to transform each sentence, split them into words and the words into representational numerical values. Okay, so copied from an example how to featurize these things, these messages, label. It looks like we are leaving it as is, which is spam or ham. I did write everything down below because it's quite a lot to put in one video. I think if you go deeper into the natural language processing domain, you'll definitely bump into all of these things. So we see this word bag estimator. We see stop words. You could even target a different language. What are stop words? Stop words are basically noise, let's say words that aren't really meaningful, essential to understand the context of the sentence. It's mostly so here are a few examples of stop words, and those will be filtered out because they're not too meaningful for knowing whether something is spam or ham in our case. Let's see. So what's the purpose of removing stop words? Reduce dimensionality. Well, we get way less features if we cut out all of these words. And we focus on the meaningful words that carry information about the topic or sentiment, which these don't really do. Stop word filtering, we can filter them out using a predefined list. Tokenization. And then this you may see more regularly, IDF, technique that assigns weights to terms based on their importance in the document, and then filter out the non-meaningful words, I assume. What also tends to happen is bring verbs back to their base form. Let's say I'm running could be transformed in I run. For spam or ham classification, that would be fine. Let's check out this bag of words first, creating the dictionary or the vocabulary. But it's more because every sentence has a different length, well, most of them, a variable length. We can't just put different input lengths into a machine learning model. We'll see that later with the neural networks. The input is mostly like a fixed shape. So what happens here is, this is on the right hand side. Can you see my cursor? Yeah. The right hand side, you see the dictionary, and then each time we get a sentence, we're basically going to count, well, nice occurs in the sentence, so we're going to put a 1 in here. Very doesn't, so 0, they does, 1, he, 0, 0, 0, and now this is your input vector, well, the vector of this sentence. A very nice day will have the same length but different value. So let's see, very 1, nice 1, day 1, so 3 times 1, and then the rest will be zeros. That's going to be your representation of that sentence. Then there's another concept, n-grams, which should help to learn about, well, evaluate the context of a sequence of characters or words. For example, my book is different than book hotel. So it seems to be that we're using these n-grams to, instead of featurizing every word individually, to maybe to make some pairs of words. For example, free gift. And I assume we're putting free gift into the bag of words instead of free and gift. And this way, yeah, free and gift will be given a representational value in the feature vector instead of the words separately. And then a feature vector containing free gift, I assume it's going to be more frequent in spam messages. Okay, so that was quite the amount of new concepts. And yeah, we will definitely bump into those if you dive deeper into natural language processing, whether that's using statistical models or neural networks. Okay, then same as usual, we train the model, consume the model. Let's see, after all of the featurization, we use of course, the naive Bayes trainer. After setting up that pipeline, the training pipeline, we train the model based on the data. We don't have a test set in this case. We'll be evaluating the model a little differently. Let's see, we consume the model, we put in a few messages: free medicine winner, congratulations, get your garden ready for summer, free selection of blah 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 blah, which seems to be more like a promotional message rather than a scammy one, but promotional can also be spam. First payment is ready, this is definitely spam. This other one should definitely be spam. This free medicine winner actually as well. Let's see, we'll do each prediction. Unfortunately, since as we saw the distribution of our data, there's way more samples for ham than for spam, so I assume that is the explanation for why the model is performing poorly. It's very biased towards ham for all the unseen new data. Free medicine winner does ham. Spam, which is literally a sentence that I copied out of this spam, so you can see the amount of ham and spam samples. I think we would like a better balance. So these are the spam ones, normal text, and the ham ones. These are the spam ones, get your garden ready free. This is literally copied from there. And that's the only reason I think it got it right. Normally you don't want to do that. Oh. Yeah, it's not performing too well. Now, evaluating the model, we're doing something differently. We're doing cross-validation, which cross-validation is basically going to split the data into multiple folds. 5 or 10, we've got 5 here. Each fold will be used for testing. Train and evaluate the model on each fold. Train the model using all but one of the folds. So we're basically going to keep one fold for testing. Yeah. Calculate an average performance for each iteration. Okay. So we're taking 5 folds. Let's see. Then it should hold 1 as, well, for training, 1 for testing, and then I think it's going to switch for each fold. It's going to have different training, different testing. Train a model on each, well, train a model each time and evaluate it. Let's have a look. Metrics for fold 0, accuracy macro, close to 0.9. Oh. Micro is higher. Close to 1 the better. Okay, log loss seems to be pretty high. But yeah, fold 1 seems to be better. Accuracy macro. Fold 2 worse than the previous. Oh, sorry. Fold 2, fold 3, fold 4. What I then found interesting is you can actually access the confusion matrix, so the true positives and so on, to see how many times did it get it right and wrong. So these 34 are wrong ones. These are correctly predicted true positives, and these are correctly predicted true negatives. No, or yeah, something like that. Okay, and all the rest is analyzing the metrics. I would ask you to try to get an understanding of that. I find these accuracies seem pretty high while our model is completely garbage. How did that happen? One of the assumptions is the imbalanced data, like way more spam data. And then I guess we could try to optimize the hyperparameters or featurization. I'll leave it at that. I just want to show you how to implement different types of models and give you a basic understanding so you can explore on your own. Likely when you find a use case, you'll want to test out different models and maybe different techniques to clean your data or optimize your data, optimize your models. Again, I will publish this notebook on my members only or on the Patreon. Do check out previous videos if some of these steps went too fast. I'm going to try to skip faster towards the neural networks and then maybe the state-of-the-art models, which are more used, and techniques and maybe AI agents. And there's so much to explore once we get some basics out of the way.